For today's lecture, we will extend the concept of determining work and apply it to the principle of work and energy. Okay, so what is this principle? In order to derive this the equation for this principle, we will be considering a particle shown in figure 14.7. We have a particle, and this particle is acted by force Fr. Now, kaning Fr, this is the resultant of all the forces that are acting on the particle. Okay? Since this is a curvilinear path, we use the normal and tangential coordinate system. So along the tangential coordinate system, we have the forces summation of F sub t. Okay, so if we resolve this Fr into tangential and normal coordinates. Okay, so if we apply the Newton's second law for this, for the tangential coordinate system, we will derive this equation: summation of force, tangential forces is equal to mass times acceleration tangential. Okay. Now, however, we replace the tangential acceleration by the kinematic equation v dv over ds. Okay, so ito nang i-substitute ang v dv over ds diri sa acceleration tangential. That is why you get this equation: summation of forces multiplied by ds is equal to mv dv. And then we integrate this one. So if we integrate both sides, okay, so pwede natin ipagawas ang summation. So we will get this equation: summation of ftds is equal to 1/2 mv2 squared minus 1/2 mv1 squared. Okay. Now, if you recall, kaning ft times ds, this is just the equation for work, right? Force times the displacement. Okay, so meaning, ma-replace natin siya by this equation: summation of work from 1 to 2 is just equal to 1/2 mv2 squared minus 1/2 mv1 squared. Now, kaning mv2 squared of mv 1/2 mv1 squared, this represents the kinetic energy of the particle. So meaning, however, we replace kaning 1/2 mv squared by the letter t. So mahitabo aning equation would be T1 plus summation of work from 1 to 2 is equal to T2. Wherein kaning T1 nimo is your initial kinetic energy. And the T2 is the final kinetic energy, no? So meaning you have a particle, nasa initial kinetic energy, i-applyan nimo work. So na-change ang kinetic energy. Nahimong T2, which is the final kinetic energy. So this is the principle of work and energy. Pasabot ani, the kinetic energy at point 1 add the work that is done on the system will result to the kinetic energy at point 2. Okay, meaning, kung naakay gusto, kung gusto kang kaning sakyanan, mudagan ni siya, ani kusga. So, applyan imo inaani nga amount of work. So, may relevance aning equation. Also, since kaning equation is gi-derive raman siya sa Newton's second law, so meaning katong mga problems sa Newton's or problems in mechanics that involves forces, velocity, and displacement, pwede po masolve using ani. Okay, well, we'll have an example later on. Okay, proceed ta sa how about kung daghang ang system is composed of many particles. So ang buhaton ni man is just you sum up the initial internal energy of initial kinetic energy sa imuhang different particles, you add the work, it will result to the total kinetic energy. Okay? Okay, so let's have an example. This one. You have a 3,500 pound automobile travels down the 10 degrees inclined road at a speed of 20 feet per second. If the driver jumps on the brakes, causing his wheels to lock, determine how far is the tires skid on the road. The coefficient of kinetic friction between the wheels and the road is mu k is equal to 0.5. Okay, so again, since nag-involve niyo work, ang katong notation na to sa work, the same ra gyapon to. No? Positive kung the same sila direction sa displacement. Okay, so let's have an example, and we have a 3,500 automobile that travels down the 10 degrees inclined road at a speed of 20 feet per second. If the driver jumps on the brake, so yung tumba ng brakes, no? And then, causing his wheels to lock, nilock ang ligid nimo, so dili na mag-rolling. So, ang nahitabo, nag-slide na nag-skid na ang imong kanan. So, determine how far is the tires skid on the road. So, unsa daw kataas no, gikan sa pag-jam niya until mahunong siya. Okay? The coefficient of kinetic friction between the wheels and the road is 0.5. Okay? So what is asked is S. Okay? So if we apply the principle of work and energy, okay, T1 plus work 1 to 2 is just equal to T2. This is just 1/2 m v1 squared plus summation of work from 1 to 2. Okay? So asa dapit ang na-is diri? Wala diri no? Kinetic man eh. So probably naa diri. Diba? Kaya ang imong work is just force times distance, kaning distance. So diri na to makuha ang S. Okay, so before we can get to work, we must draw the free body diagram. So in your solution, dapat na free body diagram. Wala yung free body diagram, your answer is not valid. Okay? Kung morning mong car, okay? First, nakakay weight. mg. Nakakay normal component. NC. Isa pa. You have friction. Okay? Kana lang ba? Okay. So, ang imong motion is paana. Right? Therefore, ang imong work, summation of work from 1 to 2 is just 10 degrees ni. It's just kani siya. Right? Kani minus frictional forces. Right? So, unsa na siya? This is just mg, ang imong mg sine 10 minus frictional force mu kn, oh by the way, mu kn multiply na nato ni s kay pareho naman na sila. Okay, so nakita na nato ang ato ang S nga component or ang atong gipangita. Okay? Okay, so this is in English system. So 3,500. Unsa di siya? Mass ba ni? Is it the mass or is it the weight? Okay? Wala gyud ano. But in the English system, 3,500 can be mass. Ang mass ani niyo nga car is 3,500. Ang weight ani is 3,500 pound force. Okay? So, mao nang wala na niya butang yung pound mass ba na pound force. Okay? Yun sa napagkahitabo. Okay, di ba? Ang recall, ang imong weight is mg. Okay? So, kung ang mass nimo, if you have 3,500 pound mass, 3,500 pound mass, so mahimo ni siya, kung kuhaon nimo ang weight, 3,500 pound mass, times ang g nimo is 32.2 feet per second squared. Right? So, ang answer ani would be 3,500 pound mass, ano? Dito lang na to equal, no? Pound mass feet per second squared. Okay, so okay, i-convert nimo ni sa to pound force. 32.2 pound mass feet per second squared is 1 pound force. Tama? So, that is why 3,500 pound force. Tumaw na siya. No? So, dapat familiarize mo sa English system. Diba? So, meaning, pareha sila og numerical, no? So, kung ang weight ang atong panitaon, so if this is the weight, ano na din eh? This is just 3,500 sin 10. Sin 10 pound force minus mu sub k, ano? Ilang k? 0.5 and 6 times s. Okay? So, pagkitaon nato ning NC nga component. So, ang NC is makuha nimo by summation of forces along kani, along diri, along y, tang atong y na. Okay? Summation of forces along y is equal to 0 because there is no motion along y. Mahimo ning NC is just mg cosine 10. So this is just 3,500 cosine 10. So pila na siya. $3,500 3446.83 3446.83 pound force. Okay? Mahimo na ning kani 3,500 sin 10. 607.77 minus pound force times S. Okay? So, saan na siya ron? Okay, take note ng this is your point 1, this is your point 2. Okay, so siyempre, muhunong running car mo or muhunong running ang car sa S kung wala na siya velocity. So, therefore, 0 din eh. Final velocity is 0. So, may tabo nga 1/2 3,500 pound mass. Sulat nimo ang unit, no? Kaya lahi ang unit sa pound mass o pound force. 3,500 V1. V1 is 20. 20 squared. Ang unit pala na feet squared, second squared. Is, by the way, pila man eh. 607.77 minus 3446.83 negative 2839.06 times S. Ang unit is pound force. Okay? So, ito nang i-add ang kani mo ang kinetic energy at point 1 plus the work. So, kani plus kani. So, minus 2839.06 S is equal to 0. Ay, pwede. Pound force ang unit. Okay? So, para the same, atong i-convert ni. Feet square, so do ka feet. So, atong i-convert 32.2 pound mass feet per S squared 1 pound force. Okay, para same unit, cancel na dahil ni. Okay? Therefore, S is equal to 3,500 divide 64.4 divided by 2839.06. Answer is okay. So, by the way, natin na overlook. Okay, so you have overlooked something here. So this value for the normal component 3446.83 must be multiplied by 0.5. So 172 3.41. Okay? So ma-change na ang value ani 1723.415 minus this is just 115.645. Okay? Ano na yun ito eh? Times this. 115.645. Okay. So, final answer is 19.5 feet. Okay? 19.5 feet. So what have we discussed so far? Okay, so we just apply the principle of work and energy. Based on this equation, zero imo ang final kinetic energy nga naman kay mahunong naman ang car nimo ni 0.2. Then we get the value of the total work. So this is the value of the total work. So ang forces na involved is just the weight component and the frictional forces. Okay, so again, this is just another way of solving the this problem, but we can also solve this one using our previous topic, which is about the equation of motion, summation of force equal to ma. Okay, so if we let nga kaning direction dani is x, so summation of forces along x, max. Take note nga ang s ang atong waon. Therefore, so positive padulong dire. So you have mg. So weight 3,500 pound sine 10 minus mu k in, so 0.5 times nc is equal to mass. Again, the mass is 3,500 pound mass. Kani pound force ni hatik not. Then AX. Okay? Pangitawon po na to ang NC. So using summation of forces along Y, NC is just 3,500 pound force cosine 10. Okay? So we have 0.5 3,500 cosine 10 pound force again we need to convert pound force into pound mass. So 1 pound force is 2.2 pound mass feet per squared. Alright? Cancel na ni. Ano sa makancel ang pound mass? So, ang nabilin is feet per second squared. So, therefore, AX is just 8,500 sine 10 times 0.5 times 32.2 divided by 3,500. Answer is negative 10.3. Okay? So negative, mali ba ni? Take note nga ang imong car ani is nag-decelerate, no? Nagkahinay ito na palong. So mo nang negative. No? So imo pong double check pod nimo. And then since dili man ang S man natong gipangita, we will apply the kinematic equation. V squared is equal to plus 2A S minus SO. Okay? So, ang final velocity 0. 0 is 20 squared 2 times A. Into 10.3 times S. Okay, therefore S is just 20 squared divided by okay. So the answer is 19.5 feet. Okay. So dapat the same ang answer. So hopefully you understand the concept and just practice solving para master right ninyo ang concept.